let's read that question. So this question is you gave you 1 to n is not repeat. So only 1 to n exactly once. Okay. So he defined confused. What is confused? Confused mean is like the pair larger than you. So here is sample 1 4 3 2. So because 4 and 3 is one pair, so it's confused. This one is confused. 4 and 2 is confused. So basically, this have 3 confused here, right? So for this one, have 3 confused here, right? But the question is that if you give you the number, they have permutation, right? They have like 1, 2, 3, 4, so other number, like other order. The 24 permutation here. So each permutation you generate a different number, and you ask you the pair, right? What is exactly the pair? He give you C here, like 10, 1, something, right? So this kind of question, how we solve this problem here. First of all, we gotta say 1, 2. So basically, all permutation, they always have one, like 1, 2, 3. If you all in order, like 10, right? If you in order, you always 0. If this permutation, you always have 0 here, right? If you in order, because you cannot pair anybody, everybody less than this previous one, so this is always be 0. Yeah. This has got to be used dp, right? So the dp is so what is dp? dp state. What is dp state, right? What is dp state? dp state definitely like is the n, right? This is n. So one number increase. If n increase, and here, because for all the permutation we have all kinds of answer, right? Like this is the answer, we have C here. We don't need a over that, right? If you ask if you ask 10 2, actually there's 10 3 4 5 6, right? But doesn't matter, we only calculation 2, right? Okay, so this is dp state, right? And how we can use previous dp solve my problem, right? This is another dp one. This is kind of like 2 degree dp, okay? So let's using this sample 4 3 here, right? 4 3 here. Let's use 4 3 here. Let's say 4 3. 4 3 is easy to pin here. 4 1 2 3 4, right? 4 3. So let's consider 1, right? Let's consider 1. If 1 sitting here, then this value, this like 4c, let's say 4c dp 4 and 3, right? So if 1 sitting here, then we just need to consider this one, right? Because 1 doesn't affect anybody, so 1 is loser. So 1 is here, so we have dp 3 3, right? 3 3. This is 3, right? Minus 1. So this notice this one minus 1, right? And if 1 move to here, right? 1 move to here. Let's say 1 move to here. If 1 move to here, what happens, right? If 1 move to here, we know this one, right? So here, still took this one out, it's still 3. 1, 2, 3, right? We know this answer. But because of 1 always less than that guy, right? So we need a minus 1, right? Minus 1. So minus 1 because we're looking for 3, right? We only need a 2. So for this dp, 3, 2, right? Why 3, 2? Because in this one we have 3 and 2. We have like exactly 3 and 2 plus, I'm in this position, I join that guy at 1, right? And keep going, right? If I put it here, what happened, right? dp. If I put it here, there's still here, still 3 number here. Still this 3 number, right? This and this 3 number, right? But my 1 pair with this 2 number have 2, so I only need 1. So this is 3 and 1, right? Yeah, let's put the last one. If the last one here, same thing, right? dp. I only need 0, right? 3 and 0, because I only need 0. This guy already paired. I cannot go further because going to the end, we're done already, right? So basically this is the answer. So what do we do here? We can, so what we can do here is looping all this previous one until the 0. We get the answer. At the end we got us. This is a recursive call, right? But this question is not that easy, right? So here is another one. Here is another, he put another difficult part is this C is 10. C is like this, right? So if you keep like looping here, if every row you keep looping, right? The first of all, there's a memory issue, right? Memory issue. This time this. If you build like this array like this, if like this, how many? 10 power 4, 10, 3, 10, 4. Yeah, if you build an array of 10, 3 and 10, 4. Maybe have trouble, memory issue, okay, too big. This too big, right? So we can, luckily for this calculation, for this one, what do? We only need 2 here, right? We only need 2. We only need 2 because we only need a previous one. So each time we have 0, 1. So this 0, 1 array will solve this problem. Every time we use 0, calculation 1. Then we copy the 1 back to 0 and keep doing. At the end, we just took either 0 or 1, whatever you did. So this is a memory issue. Also, when we do this one, for every row, you gotta repeat this time, right? See, if I calculation this cell, I need to repeat this. If I calculate that cell, I keep repeat. This is n squared time, right? N squared time that one is 10 power a. I probably like passed already, right? So this one kind of not working, sort of not working, right? Okay, here you need another optimize. This is our 2D grade DP. That's great of 2D grade DP working. This, we named this to this. We saw this pattern many times. For this kind of question, we can draw the picture for 2D, right? 2D is very easy to represent here, right? Here is 4, here is 3. Use 2D, we can easily figure out what's going on here. So let's say here, this is what we're looking for. 4, 3, right? 2D, remember 2D, 4, 3. What are we looking for? We're looking for going all the way to the request, to the 0, right? So we have like this one, 3, 3, 3, 2, 3, 1, 3 0. It's 0 1 2, right? So basically now we use picture, we clearly see this guy just equal to this one. How big? How can we go back here? Right? How many things we go back here is like depends on this number, right? Depend on this number. 3. Depend on this number. Depend on this number. That's it. This is N. This is C, right? Okay. So try to optimize that one. Try to optimize with this one. We realize because this one equal to that one, right? All we need is this one plus this one. So I will say this one. So this one kind of like equal to this one. That one equal to this things here, right? So does that mean this one just equal to this and this add up? Okay, yeah, but here we got to more careful. We saw this pattern, but we got to more careful with this C is bigger than N. Yeah, here let's try 5, right? Let's say dp. If we do dp 4 and 5, right? What's it look like? 4 and 5, right? This is bigger than this one. We gotta clearly understand that things was bigger than 5, right? So here, what do we do? 4, right? Because only 4 number here, right? So what do we try? How many times? 1, 2, 3, 4 times. We try 4 times. We cannot try 5 times, right? So what do we do here is dp. We try 3, 4, right? We try 3 and 4 because when we put it here, that's 3, 5, sorry. We try 3, 5, right? When we put it here, it's 3, 5. When we put it here, it's 3, 2, 3, 4, right? Again, right? 3, 3, and 3, 2. After you try 3, 2, no more try. Yeah, here from this training we know 4, 5 and 4, 3 is different because the 4 is mean we gotta try 4 times, right? And the 5 we still have things to go. 3 we reached 0, so right. For example, here is 4. This is 4. This is 4, and this is 5. Right here, this is 4 and 5, right? So what do we gotta do? We gotta keep going, try 4 times, right? What do we have here? Here is 4, 3, 2, right? Like this, right? So we stop in the 2 here, right? But before we go to the 0 here, right? So we go back, hit the 0. If like we have 2 here, is 4, 2 here. If we try the 4, 2 here, then we keep going here. Let's say we try 4, 2 here. If we try 4, 2 here, right? This is 4, 5. If we try 4, 2 here, we try here, 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 here. We try it until here, right? But this one is out of boundary, so we tried it until here. Look like we tried 3 times. Actually, we need to try 4 times, right? Okay, so if we try 4 times, we will find that the tricky here is every time we try the 4 times here. So for the 4, for the like 4, 4, for the 4, 4, this is 4, 4. Our original plan is add this one and add this one, right? But for the 4, 4 here, is go back 4 times. We still have 4 times to go here, right? So 4 is go back 4 times is here, right? All we want is this one, right? So if we add this one and here, so we will add extra one for this one. Yeah, for this one, right? So now we know we need to minus this one. So basically the answer should be this. If we're looking for this answer, it should be here and here and this one, the last one. Last one is like F, M, C, right? Last one is C minus N, right? 5 minus 4 should be 1. Should be last one should be 1, right? Last one should be 1, and but if this one is less than 0, we took 0, right? Because 0 doesn't mean anything, right? So last one should be 0, right? So it's greater equal than 0, right? If here, if outside is 0, we don't do that. So we don't do that, right? So we don't minus this one, nothing to minus, right? So basically, from the code, we can say, yeah. So we also can have the 2 parts. This part, this is 1 part 2, part 3, and this is the 1, right? If this one greater equal to 0, we took that. If not, then it's not exist. So we just here, then you don't need a minus that one. That's the whole solution, right? So basically, from this question, they build is like. So first of all, this is DP. So this is 2D grade DP, and basically we learn from the picture. So it's very easy to represent everything. So we need to draw the 2D and find the grade. This one belong to which one, right? And also there's another tricky part. They force you to figure out this formula. If you don't figure out the formula, and you will TLE, because if you keep adding this one for each one, for every node you keep calculation, looping the calculation, it will be TLE. So you need to figure out only 3 move, right? 1, 2, 3 minus this one. And yeah, so we learned this one. First we can using this number, the real number, to if we really difficult to figure out what's going on here because it's too abstract. So we can use real number to do the testing, and we can use the real number do this testing, and we can figure out what's going on here. At the end we find a formula, we can coding this one. It all depends on this see this number design all important. Also we learn another two. So for the 2D interval of for 2D agreed DP, we can use 0, 2, 0, 1. Where's my 0, 1 here? Yeah, 0, 1 here, right? 0 and 1. Well, 0, 1 is probably in here. Yeah, we lost 0, 1, right? We can use array. We don't need to define like huge array here. We can only use 2 row to represent, right? If like this 2D, for example, sometimes funny way is if we calculation this 2D request let's say request here and here something here, and you just use 3D, right? You can use 3, depends on how the formula, how the previous we have, right? You can from previous here with TLE, right?